Welcome to Across the Globe. Today we will learn about testing in Go. Testing in Go is crucial for verifying the reliability and correctness of code. By writing tests, you can validate that your code functions correctly in different situations. Go offers a convenient built-in testing framework that simplifies the process of writing and executing tests. This allows developers to easily verify that their code behaves as intended, enhancing the overall quality and robustness of the software. For example, a scenario where testing in Go proves beneficial is when developing a web application that must handle different levels of user traffic, ensuring that the application performs consistently under varying loads. When writing tests in Go, it is crucial to follow specific conventions. Test files should have a suffix of test.go, like filename test.go. Test functions should start with test, followed by a capital letter. For instance, func test my function t testing.t. Additionally, the testing package is utilized for creating test cases and assertions. This structure ensures clarity and consistency in your test files. For example, if you have a function named calculateTotal, the corresponding test function should be testCalculateTotal. By adhering to these conventions and using the testing package effectively, you can create robust and maintainable test suites in Go. When conducting tests in Go, you can utilize the go test command followed by the package directory for execution. For instance, go test /. By employing this testing framework, you can observe the results of the tests, which will comprise any failures or errors encountered during the process. Upon a successful completion of the tests, the output will showcase OK to signify the positive outcome. An instance of this in action would be running go test / on a Go package directory to evaluate the functionality of the code within the package and affirm its correctness. The provided code showcases a basic Go function named add within the math.go file that simply adds two integer numbers. Additionally, a corresponding test is illustrated in the math.test.go file to verify the correctness of the add function. The test includes an assertion to compare the result of adding 2 and 3 with the expected output of 5. If the result does not match the expectation, an error message is generated. This approach follows the fundamental testing principle of ensuring that the actual output of a function aligns with the anticipated outcome, thus validating the expected behavior of the code. In conclusion, the integration of unit testing, as demonstrated in the provided example, aids in maintaining code quality by automating the verification process and enhancing the reliability and robustness of the software. Testing in Go is like checking the ingredients of a recipe before cooking a dish. Just like how you verify if you have all the necessary components for a meal, testing ensures that your code has all the required functions and features. Without testing, it's like cooking without knowing if you have all the ingredients, leading to potential errors or bugs in the final product. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website, across the globe, www.atg.world. The analogy test.go file in the above code snippet is used to write tests for the functions add numbers and subtract numbers in the analogy.go file. The test add numbers function tests the add numbers function by calling it with values 5 and 3 and checking if the result is equal to 8 as expected. If the result differs, an error message is printed with the expected and actual results. Similarly, the test subtract numbers function tests the subtract numbers function with values 10 and 3 and expects the result to be 7. If the result is not 7, an error message is printed. By running go test in the terminal, the testing framework in Go will execute these test functions and provide output indicating whether the functions passed or failed. In case of failure, the specific details about the expected and actual results will be displayed to assist in debugging and fixing issues in the code. In a real-world scenario, this testing setup can be beneficial for verifying the functionality of mathematical or calculation functions in a Go application. For example, In a financial application that performs complex calculations, writing tests like these can ensure the accuracy of the financial calculations and prevent potential errors or bugs in the code that could lead to incorrect results. One industrial example of using testing in Go is in the development of web applications or APIs. By writing tests for different endpoints, handlers, or middleware functions, developers can ensure that the application behaves correctly under various conditions and that changes or updates do not introduce unexpected bugs. Another real-world application of testing in Go is in the realm of microservices architecture. When building microservices that communicate with each other, having comprehensive unit tests, integration tests, and possibly contract tests implemented in Go can help maintain the reliability and consistency of the overall system. Testing in Go provides confidence in the functionality of software components and systems, ultimately contributing to a more robust and stable product for users worldwide. Across the globe, keep learning, stay curious, and I'll catch you in the next video.